morning. I am JAYANT from University, Chennai, and I have done my engineering 2009 to 13 batch, and I am going to deliver my project report. And my topic is Structural Insulated Panel System for construction of a residential building. And my project partner is Mr. Suraj Verma. He is also my classmate. Now, my objective is to make a study on a structural insulated panel system for construction of residential building, submitted by me and my project mate Suraj Verma. We are both from Weltech Dr. RR and Dr. SR Technical University, Chennai, 62. Our internal guide is Mrs. S. Durga. She is assistant professor from my university. This one is abstract. Constructions of residential building the traditional method with the use of brick, cement, concrete, etc. requires heavy masonry in large labors and long time period, which in turn requires heavy investment and makes the construction very costly. The poor people can't afford such costly tasks, but rich people can afford. For the betterment of these situations, there is one new technique, a structural insulated panel system, which is very fast, energy efficient, and cost effective. In this technique, building of house mainly done with the insulated panels, which tied with LGS assembly with the foundations. In this report, we have done some tests on the panels, its deflections, to know its loading capacity. We have also explained its advantages over reinforced concrete structures. SIPs are strong, energy efficient, and cost effective structure. Research is going on to make advancement in this technique. This one company profile. Composite Technology Park is situated in Bangalore. It is a society for developing composite, which was incorporated in 2003 as a registered R&D society, supported by Department of Science and Technology, Building Materials and Promotion Councils, Department of Housing, Choir Board, Government of India. This also includes construction of a structural insulated panels house. This company is run under the Executive Director, Dr. R. Gopalan, who is Company Executive Director and CEO. First of all, we will all know what is SIP. SIP is nothing but Structural Insulated Panel System. It is a technology to construct new structure within short span of time and cost effective. SIP basically two facing of orient strand board bonded together by a high pressure injection of polyurethane closed cell foam. It also consists of light gauge steel, orient strand board, and polyurethane cell foam. You are viewing these diagrams of structural insulated panel systems. This is the panels, this is OSB board, this is EPS foam, and this is bonded together by an adhesive. And usage, its use is in residential building, office building, resort or temporary checkposts, or traffic cabins between roads, etc. It's vital used as roof and external walls. However, they can also be ideal for floors and internal walls. Structural insulated panels materials performance. Increased insulation composite can significantly reduces costs for heating and cooling and lower utility bills. This is literature review research given by P. Rusmi and K.L. Devries. Test of material. Test of material is done as per RB TEFAC standard of Composite Technology Park, Bangalore. Test on composite material. The following tests were conducted on the surface to check its characteristics features such as tensile tests, flexural test, deflection test of biaxial panels. Masonry used. We have used universal testing machine whose total capacity is 50,000 kilonewton. You are viewing this universal testing machine whose total capacity is 50,000 kilonewton. With the help of this, we can do compressive. We can check out the compressive strength, tensile strength, and flexural strength. This we have calculated physical properties of coir composite laminates of thickness 8 mm, and we got that average density is 960 kg per meter cube. And for the same material, for the same thing, we have done tensile test of coir composites, and we found that average tensile strength is equal to 18.08 Newton per mm square, and it can resist maximum tensile load is equal to 3,569 Newton. And second one, we have done flexural test of coir composite laminates 8 mm, and we got average flexural strength is equal to 1.7 Newton per mm square, and it can resist maximum flexible load is equal to 1086.4 Newton. Third one, deflection test on Bayesian panel. We have done deflection test on the Bayesian panels to check its deflections, and we got deflection is equal to 1.5 mm by putting total load is equal to 213.2 kg, and we have done deflection test both right side and left side, and we got that total deflection is equal to 1.5 mm. Next one, we have done case study on construction of the SIP house. This is the front view of the structural insulated panels house which we have done case study. This is the detailed dimension of the house. Total size of the house is 4.7 meter into 5.5 meter. Height of the house is 3 meter, and door is D is equal to 2.1 meter into 0.9 meter, and D1 is equal to 2.1 into 0.6 meter, and window is equal to 1 meter into 1 meter, and W1 is equal to 0.6 meter into 0.6 meter. Ventilator is equal to 0.6 into 0.6 meter. This is the detailed dimension of panels which we are going to fit around above the plinth level. This is the panel size. Panel size you are seeing. Panel size is 1.21 meter into 2.4 meter. Normally size we are using for the constructions of the residential building when we are using structural insulated panels technology. Panel thickness is equal to 0.101 meter, and area of the panel is 2.904 meter square. Okay. Volume of panel is equal to 0.29 meter cube. Length of the wall is equal to 4.7 meter. Height of the wall is equal to 3 meter. Size of the door 2.1 into 0.9 and 2.1 into 0.6. Size of the window is 1 into 1. Another one is 0.6 into 0.6 meter. And total area of the wall is equal to 61.2 meter square. Size of the door and the window next one. Window is 1 into 1 meter square. Door for 2.1 into 0.91 meter square, and for ventilation same 0.6 into 0.6 meter square. Steps of construction. How we are going to do constructions of residential building with the help of structural insulated panel technology system for the construction of house. First we have to make prepare for foundation and concrete floor as floor plan. Then we have to fix light gauge steel Q channel as per floor plan with screw above the plinth level according to the floor plan horizontally to fix the SIP wall. Also vertically we have to assemble LGS vertically at every 2 feet or wherever required in case of door and window as for support. Now we have to put assemblies and screw it wherever required. This is the floor plan of SIP house. This one living room, this one bathroom, this one passage, and this one bedroom, and this one kitchen. And it has common thickness 0.101 meter as panels, and the panel which we have used have same thickness 0.101 meter. This is the density calculation of SIP house. We have calculated the density for SIP house, and the material we used for making panels the material which we used for the construction of SIP house is light gauge steel fiber cement board, and its dimension is for light gauge steel plus EPS is equal to 89 mm. For fiber cement board 6 mm for one side and 12 mm for both sides, and total thickness is equal to 0.101 meter, and weight of edges is equal to 6 kg per meter square, and density of EPS is equal to 20 kg per meter cube. Density of FCB is equal to 1350 kg per meter cube. This is the tabulation for all the 14 walls we have calculated to find its density. And for the same, for comparison purpose, we have also calculated for the brick wall masonry its weight, and density of brick masonry is equal to 1900 kg per meter cube, and we have taken the thickness for the outer wall for the brick masonry structure is equal to 0.23 meter, and the partition wall internal wall thickness is equal to 0.115 meter. This is the tabulation and calculation for all the 14 walls for the same brick masonry structures. Now we are comparing SIP and brick masonry structures. Density of SIP wall is smaller than the brick masonry, that is 243 kg per meter cube is smaller than 1900 kg per meter cube. For the same, weight of SIP house is smaller than the weight of brick masonry structure. The weight of SIP house is 1908 kg, and on the other hand weight of brick masonry structure is 31,851 kg, and we concluded that in both case SIP is better than the brick masonry structures. This one is results and discussion. The average density of coir composite specimen is 960 kg per meter cube. The tensile strength and flexural strength of the coir composite laminates is equal to 18.08 Newton per meter square and 1.70 Newton per mm square respectively. It can resist maximum load of 3,500 Newton and 1086.4 Newton. The density of SIP wall and brick masonry is 243 kg per meter cube and 1900 kg per meter cube respectively. And conclusion, we concluded that the average weight and density of SIP wall is smaller than the brick masonry structure, so there is no use of stationary. So there is no use of heavy masonry. Strength to weight ratio is outstanding with panel weighting. This allows for ease of handling on site without the use of the crane, etc. Reduced foundation specification and cost can also be expected. Construction of brick masonry structure will at least take 3 months, but SIP can be constructed in a single day. Thank you.